coordinates. Okay? When you are given a polar coordinate, it will be r on the theta. Alphabetical order, just like any other coordinate.
XY.
Okay.
Theta falls in English.
Probably would.
Okay. So theta is the angle in standard position, and r is the distance along the terminal ray. Okay. I do not care whether you draw the angle first and then count, or count and then draw the angle, but I think it is easier to think about where you're rotating and then move out our spaces. Okay. So like if we had the coordinates 2, 3 pi over 4, I would rotate to where 3 pi over 4 is and then count out 2 tick marks. Okay, we have concentric circles as our grid lines. Okay, that we count out.
Concentric.
What did I say?
Concentric.
Concentric.
I don't know words. I didn't know.
Pronunciation.
Hold on.
It's concentric.
Concentric. Yeah, I said it.
I was
Sorry.
confused.
No, yeah, concentric. Word I didn't use very often. Okay, now let's recall. Okay, this should be easy to remember. Positive rotation, we go clockwise, negative, clockwise. What about if R is negative?
We go
Through.
Okay, then we're going to go backwards from the angle. So we're going to rotate and then move backwards. Okay? So we are going to plot some points here. Yes. Thank you for your enthusiasm.
Totally, all the time.
This is the fun part.
We expect you to maintain your enthusiasm.
Okay. All right, so 3 pi over 2.
Ooh.
Can I do it?
Do it, do
I
it,
don't
do
want to do that one. That's an easy one.
Oh, wait,
You-
there's 5 or
It's
2.
labeled, it's too easy.
Oh.
I could have gotten this.
It's all labeled.
Oh, we have to go up there?
No, I mean like, oh, you was counting.
So we rotate to pi over 2, and he counts forward 3. 1, negative 3 pi over 4. Not
Oh, that's
even
a 4,
close.
that's a 4.
Thank you. We rotate to negative 3 pi over 4, and he counts forward 1. Negative 2, 5 pi over 6.
Ooh. Can I do it?
I feel like I should.
Yeah, I should go.
Go.
Mess it up.
Dream team.
First pot done.
Yeah, we were done before you because we never even started.
Yeah, I went on the wrong line.
We're on the wrong line.
We are
What?
dream team.
He went on,
Pi over 12's on.
Yeah.
There are.
Yeah.
okay. So we rotate to 5 pi over 6, and then move backwards 2 spaces. Okay? All right. Now, I'm gonna go through this graph by plugging in values and figuring out where we go, okay? But then we're gonna go through all the shortcuts for graphing, okay? But when in doubt, you can always make an R theta table, okay? But it's gonna be easier to plug values in for theta to figure out what R is, okay? Because R is the dependent variable. So at 0, where are we?
0.
Okay. What do you want to wanna do pi over 4?
Yeah.
One.
4.
I don't know, man. Pi over 2 is 0. So what's happening in between there?
It's going back to your.
Okay.
Well, like
What about at 3 pi over 4?
-4.
Pi?
0.
5 pi over 4?
Guessing what? If we, it's -4. It's negative in the third quadrant. No, it's -4.
And it has to be probably a 5 pi over 4 is over here. If we went negative, we'd be back there.
It's gonna be 10, yeah. We're still in part 2.
Okay, so we all know how the rest of this is gonna go, right? Okay. We will get back to what all of these shortcuts are, but when in doubt, you can always plug things in and go from there. Now, before we get too much into our graphs, let's talk about converting from rectangular to polar, from polar to rectangular.
R
Okay.
sine theta, R cosine.
Okay, so let's think about just being in the plane, right? So this is theta and this is r, right?
Yeah.
This is
Cosine.
X.
Cos.
y. Whatever that coordinate is, that is what each of those variables are representing. So, equations that we can make from this.
R cosine.
X equals r cosine theta.
Y equals R sine theta. This is essentially just vectors.
Okay, what else? Nope. Okay, for this example,
We know what R and.
Are we going
okay, so I guess for this example, yes, this is all we need.
R cosine?
So for x, we have r cosine of 5 pi over 4. And for y, we have r sine of 5 pi over 4. So what is our xy coordinate?
Square root of 2. Square root of 2, square root of 2.
Both negative. Yeah. X is negative. Or the positive is positive.
Where's 5 pi over 4?
Third quadrant.
Third quadrant. So it's times
They're
negative.
both negative.
Both negative. Times the negative.
Times the negative.
Right.
Okay, now let's think about this. If we were to plot this, we go to 5 pi over 4 and then go backwards 2. That better be in the first quadrant.
It is.
Okay. So make sure you think about that. Does your answer make sense?
Yes.
Or we could just say x equals r cosine theta and y equals r cosine theta tangent.
What did you say?
Well, if you could, because y would also equal tangent of theta x.
I'm going to draw our same picture here.
Wait. Oh, okay, well.
Except it's negative 3.
Okay, so, well, I'm just drawing a picture. In general.
That's not. Like, it's in the wrong quadrant, it's gonna throw me off.
Alright,
7 pi over 4.
Stop. Stop. What equations can we make out of this triangle?
Root x squared plus y squared equals r squared.
And
Inverse tangent of y over x.
okay, you can write it like that. You can write it as inverse tangent of y over x, whatever. Okay. Now, yes, we do have a coordinate in the third quadrant. So our polar coordinate better be in the third quadrant. So x squared plus y squared equals r squared. 3 radical 2.
It is 5 pi.
And then we have the tangent of theta equals y over x, which is 1. Now, we have said that r is a positive 3 radical 2. We want this to be in the third quadrant. I know that there are 2 places where the tangent of theta is 1. Which theta do we want?
5 pi over 4.
Yeah.
Negative 3 pi over 4.
Yes, you could say negative 3 pi over 4. I could also say
Oh,
negative 3
13
radical 2.
13 pi over 4.
You could also say negative 3 radical 2 pi over 4. Okay, there's a lot of different ways you can write this
7
coordinate.
pi over 4.
It would be my preference that if you are writing the coordinates for me, you write it with everything positive.
Everything positive. Pi.
Easier to
Yeah.
Yeah. You can draw me.
All right, I want to change this into rectangular form.
Okay, let's do this, team.
Okay, so this is why I made you write down all of those equations. So x equals r cosine theta, y equals r sine theta, x squared plus y squared equals r squared, and tangent of theta equals y over x. These are all things that we could need in order to convert. Yes,
Can we use the cosine one?
can we? We could use the cosine one if there was a what in front of the cosine? An r. Can we put an r there? And we did what?
Ooh, multiply both sides by r.
If we multiply both sides by r, is that legal?
Yeah.
Of course it's legal.
X squared plus y squared
Yeah.
equals negative 8.
Sorry. We did it.
What are we dealing with?
Rose
Circle.
Dealing with
rose curve.
Look at the equation in rectangular form. What are we dealing with?
X squared minus.
semicircle.
Um,
No.
Hyperbola.
I don't know. Hyperbola.
No, what did we
Radical.
say before?
Yes.
I have no idea.
Conic section. A line.
A conic section would be correct. Let's figure out what we're dealing with, I guess. Okay, let's complete the square.
What? Oh, okay.
What completes the square?
16.
So what is it?
Ellipse.
No, what?
Circle.
No.
Circle is an ellipse.
Wait, is it a circle?
It is a circle.
Ellipse is like if there's it's like rectangles and squares.
A circle is a special ellipse. I will give that to you.
It's special. Just like
Okay.
me.
So this is a circle with radius 4 and center.
Negative 4.
Okay. by the end of today, you should be able to look at that and know that we have a circle to the left of the pole, diameter 8.
Whoa.
Diameter 8. I see what you just did there.
Okay. All right. Let's convert this.
Okay. R cosine theta, R sine squared, cosine theta, sine theta.
Let's divide both sides by y.
What did you say?
R squared sine theta, cosine theta equals no.
Well, we can do some substitutions, right?
Yeah. Probably square.
Now, when you are converting back to rectangular, what form is this? Polar form,
You said equal to R.
you want to try to solve for r. So I would write r squared equals 4. Solving for r squared is sufficient. I mean, you can say r equals plus or minus square root of blah, blah, blah. But solving for r squared is fine. So you want to try to solve for r. If there's not an r, then you want to try to solve for theta. Okay?
But it's just a line.
Okay, some symmetry. If we have x-axis symmetry, what is going to be true about our coordinates? We have r theta and we have
R negative theta.
if we have y-axis symmetry. What did you say?
I'm trying to think this.
Yeah.
Origin symmetry.
Negative R theta.
If it has two symmetries, then it has to have all three. Okay. Now we're gonna get into our graphs. You okay? No? Any explanation that you need? Do you have a question? He was imagining the axis.
Okay.
Okay.
Screw
Lines. How do we make a line on a polar graph?
Just angle,
R equals.
Not r equal.
just theta equals.
No, because that's for.
Theta equals, you're right.
Okay.
Theta equals pi over 4 is a line at the angle pi over 4. Okay? I would not write everything word for word, but theta equals a number would be sufficient. Okay? We can also, okay, if we think about the line x equals a, okay, then that would be the same as our cosine theta equals a. That would give us a line. Or r equals a secant theta, that would give us a line. Along those same lines, pun intended. A horizontal line.
R sine theta.
Equals B.
Ooh, nice.
Wow, that's nice.
There's a few ways of making circles.
Is there three?
Gotta go.
Onto the lines?
Three that you know.
R equal, or R, yeah, R equal R first one. R squared equal
R squared equals A.
or R squared equals R.
Okay,
Or R.
so R equals A. That would mean our radius is consistent throughout, so we are centered at the origin, and our radius is the same no matter what angle we are. Okay, so we're centered at 0, 0, and if that's R equals 5, then you have a radius of 5 everywhere. Okay, let's think back to the example that we did. What was the equation
R squared equals R.
before that? Okay, so R equals A cosine theta. Well, without the R squared in there, just R equals, why did okay. So I put 2A here so that I could say the radius was A. So whatever this coefficient is really the diameter. All right? If it is a cosine circle, then it's either to the right or the left of the pole. When does it go to the left? If it's negative. It goes to the right if it's positive. Along those same lines, if I want to circle above or below the pole. Okay, if the coefficient in front of sine theta is positive, it's going to go above, negative, it's going to go below.
This is if we're converting into Cartesian.
We're not converting. We're just going to graph it. But that would be, yes, in Cartesian.
Like the 2 and 3 on the circles, because those would be rose curves, otherwise we would.
Rose curves would have something here. Those are circles because it's just theta.
Because if theta's changing.
Theta's not changing at all. Theta's theta. Well, okay, as we plug things in.
Yeah. Like, on a polar graph, 2 and 3 would not look like circles.
Get your calculator out, put it in polar mode.
And now,
Make sure you got scale.
Polar mode and radian mode.
2, we'll make it just 2 cosine. Graph.
So you should have to the right of the pole, it's a circle.
whoa,
Scales.
you can get to that on
Yes.
Oh.
Wow, Kathy. Okay.
Someone else said line of time first. It's not my fault. Oh no.
Where do we get the line of code?
First I was like, line of first. Definitely making a pun.
Okay, so they're going to be in the form R equals A plus or B cosine theta, R equals A plus or B sine theta.
Plus or B.
Plus, yeah. You know what I mean?
Hey, she has a kid who's getting
What?
shot in the toe tomorrow. She
Yes.
doesn't need this right now.
Very true.
It's gonna kill his tongue.
What they have to cut out. Sine cosine determines what?
If it's x-axis symmetrical or y-axis symmetrical.
So if it's sine, it has what kind of symmetry? Cosine. Okay. Plus or minus determines?
It's a plus and minus.
If it's A plus B, or if it's A minus
Whether
B.
it's on the right side or the left
Okay.
side, top.
Where the majority is, I'm gonna write.
I read x-axis.
It's not a shift.
Center.
Could go up.
It's where it stretches more to.
Yeah.
Okay.
A plus B determines the max.
Good. A plus B determines the max R value. A divided by B determines.
What kind it is.
Okay. I just stole the slide from my pre-calc notes. We're not going to go through the direction of the limacons and where it opens because I think you guys, well, where a majority of it is. Okay. So if it's sine and it's positive, then a majority of it is going to be above the pole. If it's cosine and it's A minus B, a majority of our limacon is going to be to the left of our pole. Right?
Yeah, because it's like dimple.
This is a loop. If when A over B is
Loop greater than 1. Less than 1.
less than 1.
First try.
Okay?
Are you Batman?
Because either the A plus B or A minus B, or A plus B, I guess, will give you a negative value and then it will create the loop. This is a
No, that's the next one, right?
Cartesian or
cardioid, and that is
It's
when
like a part. Oh, that's 1.
A over B is 1, so A and B are the same.
Dimple.
Dimple.
How is that?
Cardioid.
Like that's what makes me think cardiac. Because the OI what makes the voice.
Yeah, the
What?
pointers are on.
Cardioid. Cardoid. Let's do
Dimpled is what A over B is,
Is that like
and then this is convex. When A over B okay. Last ones. Oh, these aren't the last ones, but you don't have to write these down.
No!
No, you don't have to write these down. You don't have to remember these, but these are some cool ones. Yeah, but it's,
Newly I know.
Mistakes for doing.
It's a new. It's for new. You spelled
Yeah,
Okay.
there's a second I in cardioid.
Is there?
Yeah.
I remember there were 2 different ways of spelling it. There's one with the T where it's just cardio, like spelled
the
how
one
she
that
spelled
I
it,
found
and then
has
there's
a
one,
D.
yeah, where the D on Wolfram Alpha that's got it with 2 I's.
Is it pronounced the same?
I don't know.
Okay, let's talk about our rose curves.
But we got a cardioid on.
What does A tell you?
It tells you the maximum distance.
Okay, so I'm gonna say length of petals. Okay? What's the difference between sine and cosine?
One is x-axis or the symmetrical.
Okay, well cosine is gonna have
Oh, where you start and stuff, right?
symmetry along the x-axis. Sine is gonna have symmetry along the y-axis.
Doesn't one only have like even numbers of petals?
That's gonna be n. That's what n is gonna tell you. Okay. Now, when we have a cosine one, we're always going to start on the x-axis because the cosine of 0 is 1.
Yeah.
So we're going to get a value. When it starts at the origin, that is a sine curve. Okay. Then n. If n is odd, how many petals are there?
2 and not just n.
If n is even,
2n.
then there are 2n.
How do you get 2 petals?
Yeah.
That's
Bernoulli. I want to learn more about this Bernoulli guy.
Okay.
I don't.
So I have 3 graphs. We'll see if we can get done. Okay. -5 cosine theta. Nate,
Oh.
what is it?
I don't know.
Oh, it's in it.
Is it one or the other one?
It's a circle.
Yeah, right.
It's a circle.
Green left.
With a diameter of 5.
It's a rose curve with 1 petal.
You could also think
It's
of
a
it.
dying rose.
Well, I mean, technically,
Yeah.
Technically, it is a rose petal. Not rose curve, but rose petal. Rose curve, with just 1 petal. Okay. What would the zeros of this be?
-5.
Pi over
Negative
2 and 3 pi over 2.
-5, -5, 0, 0.
I'm going to go with pi over 2 and 3 pi over 2.
How many times does it go through?
Twice. 3, 4.
Well, if we plug in 0, we start right here. How many times do we go through?
Just once.
So we have 1 0.
Sorry.
Oh.
When we have an even number of petals, it's only going to take from 0 to pi to draw that curve.
But one's off.
I mean, hold on. When it's odd, that's what I meant. When it's odd, it only takes from 0 to pi to draw. Okay. All right. 4 petals of length
2.
2. So we would begin when theta is 0, and that would give us an R value of 2.
That means there's got to be 1.
There's 4 petals, so we know they have to be how far apart?
5, 2.
Okay. Count how many times you go through the pole.
1,
2,
2, 3, 4.
4.
So we would have 4 zeros. How would we find zeros?
Guess and check.
So,
Pi over
Pi over
4.
2. Set R equals
I
0.
have pi over 4. And pi over 2.
So 2 theta would be cosine of 0 at,
Pi over 2, pi n, plus pi n.
okay, so pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. I listed 4, because I know there's 4 zeros, so are zeros.
This is the stuff that we did yesterday.
This is the stuff that we did yesterday. I gotcha. Yeah. When you are graphing rose curves, make them look a little prettier than this one did. When it's a sine curve, you're going to have to figure out where that first petal is going to go. But I'm confident that you can do that.
Yes.
With some practice. Okay? A limacon. I will tell you, if you're going to graph a limacon, just plug in
Where it gets you.
the axes for theta values. So 0. First of all, what kind of limacon is this?
It would be convex.
It is convex.
Yeah, it is.
Yeah, because A is, because our ratio is 2 or more. Okay, so if we plug in 0, we get R is
4.
If we plug in pi over 2, we plug in pi. And if we plug in 3 pi over 2. So we start here. How many zeros do we have?
0.
We don't go through the full, we don't have a 0. Now, why am I going through each of these graphs and why are we taking a whole day tomorrow to graph them? Eventually we're going to find the area.
Oh.
Oh, yeah, that'll be fun.
So it's important that we know how to find the zeros.
That way we can derive
Okay.
and then integrate.
Like I'm going to make you find the area of a loop
Oh, yeah.
of a line. Okay. So tonight I'm going to have you practice just some converting.
Well, the school's almost out.
Yay!
Yeah.
Here we go.
No school. Cheaper.
What I will do, since I will not be here tomorrow, I'll leave the solutions menu up here. So if you have an issue with a problem that you can't see on Calc Chat, then you can look it up in here. Okay?
Yeah, I have a video on Friday.
Decrease the steps, see what happens then.
Let me get you the worksheet though, Jared.
I don't know. Dude, I got really excited. I'm like, wait, we're watching a video on Friday.
Wait, video day Friday?
No.
What is that movie that we're supposed to watch?
Rector Day on.
Oh, director. Cool. Okay.
Stand and deliver. Yeah.